In this lesson, we will introduce discrete random variables. In the introductory video on probability, we defined a random experiment, like for example, tossing a fair coin twice. And every random experiment has a sample space including all its possible outcomes. When tossing a coin twice, for the first toss, we can have a head or a tail. For the second toss, if we had a head on the first, then we can have a head or a tail on the second. Similarly, if we had a tail on the first, we can have a head or a tail on the second. Then for the sample space, we have two heads, a head then a tail then a head, and two heads, which give the sample space of the random experiment given. But what does this have to do with a discrete random variable? Well, a random variable is a quantitative variable defined on the random experiment that could be both discrete or continuous. For example, on our random experiment, we can define the random variable x defined by the number of heads obtained, or the random variable y defined by the number of tails obtained, for example. Now let's take the random variable defining or considering the number of heads obtained, which in this case is a discrete random variable. When defining a random variable, we must specify the possible values that the variable can take. For this random variable, when tossing the coin twice, we can have no heads, which gives x equals to 0. We can have one head, which gives x equals to 1. And we can have two heads, which gives x equals to 2. So x can take the values 0, 1, and 2. And these are called the elementary events of the random experiment. And every random variable, whether discrete or continuous, is defined by a probability density function, also referred to as the PDF of the random variable, which consists of a table for a discrete random variable, where in the first row we list the possible values of the random variable, and the second row, the probabilities of the elementary events. So the first one consists of obtaining no heads, with the probability of x equals to 0. In our sample space, only one outcome out of 4 has no heads. So the probability of x equals to 0 is 1 out of 4. The second one consists of obtaining one head, exactly one head, with a probability of x equals to 1. In our sample space, we have 2 outcomes out of 4 that have exactly one head. So the probability of x equals to 1 is 2 out of 4, which reduces to a half. And the last one consists of obtaining 2 heads with a probability of x equals to 2. In our sample space, one outcome out of 4 contains 2 heads, then the probability of x equals to 1 is 1 out of 4. And the sum of the probabilities of all elementary events is 1, as elementary events combined give the entire sample space of the random experiment. Now, based on the probability density function, we can obtain the probabilities of x smaller or equal to a, which define the cumulative density function of the random variable, where to calculate the probabilities, we bring down the first one, then add it to the next one, and again, add it to the next one, and so on. And the last one should yield the total probabilities, which is 1. Now, for example, to have the probability of x smaller or equal to 1, you could add the probability of x equals to 0 plus x equals to 1 as 0 and 1 are both smaller or equal to 1. Or we can take the cumulative probability of x equals to 1 from the cumulative density function.